there's a good chance that they're gonna get shocked. Cannot use these for a 60 amp charger. This one is amazing. Very good. I love it. Let's get the bags on. Let's get moving. Make sure we get our safety glasses on and our gloves on. Always gotta be safe. All right, guys, so I'm super stoked today. What's up, Paul? Yo. What we got going on is a 240 volt outlet for an EV charger that's gonna go in right over there. This house already has wiring set up for it, but I'm gonna show you a little bit later in the video if you have an older panel and you need to get a chase down, a conduit where it needs to go, and then mount an EV charger inside your garage. We're gonna show exactly how to do that. Our friends over at Lighter Electric, right here, you can see them. Lighter Electric, they sent us a bunch of products to review, and honestly, I think that they are at the top of the market now for industrial rated NEMA 1450 outlet. So they sent us 2 of them, or 3 of them actually. There it is right there. Lighter Electric, NEMA 1450, industrial rated outlet, 240 volt. It's got the EV charging symbol right there. Weather resistant if you want to install it outdoors. So here's one that they sent us. They also have it in a few different colors. Look at that. If you want a gold one. Also, silver one. But what I'm most excited about, Paul, is right here. Look at this bad boy. I've spent a ton of time talking to these guys, and I am so impressed with the junction box that they chose to use. I mean, look how big this one is compared to the other ones. It's super wide. That's one of the issues that we have with all the other ones. They're so narrow that it's really hard to get the wires to turn where we need them to go. See the difference here? That little tiny space to get all the wires in as compared to this one, it gives you a lot more space in here. Yeah. They also have the flip cover, weather resistant, and it's already installed in here. And it's in stock. What we're gonna do here, this is not the panel that we're gonna go from. We're gonna go from the exterior panel on the other side. This is a newer house, so it already was wired for having an EV charger rated at 50 amps. Nice. So they used Romex though, not THHN. We've gone over this. Yeah. Romex is rated for 55 amps. So if they wanted here to put a 60 amp charger, they'd have to use THHN. Mm-hmm. We're not doing that. We're putting the outlet in. And then what else do we need to install on the outside when we put a NEMA 1450 outlet?
A GFCI breaker.
GFCI breaker. Yeah. You have to have a GFCI breaker on any 240 volt outlets that are installed now. The most critical thing when we're doing this is to make sure that nobody gets hurt, right? So what we're gonna do here, and I do not recommend you do this without consulting a licensed electrician and having someone else install this for you. The safest way to do this is to turn off every breaker in your house and turn off the main breaker. As I said, I do not recommend that anybody who's not a licensed professional do this. Make sure you turn off the power to the house. All right, so let's go out to the main panel real quick. All right, here's our panel. Okay, so we got a 225 amp breaker here. This is our main breaker in this panel. So before I do anything, I'm gonna turn off all of these branch circuit breakers, then I'm gonna turn off the main breaker. So what we're gonna do is what's called a live dead live test. So we're gonna check with an electrical meter that the power is on, and then we're gonna turn off the main breaker. Then we're gonna check that the power is off, and then we're gonna turn the main breaker back on one more time, check it one last time to see that the power came back on so that we know our meter is working, and then we'll finally turn it off again. So live dead live, that's what we want to do here to make sure that we are safe when we're working inside this electrical panel. Always put your screws back in, right back in the hole so you don't lose the screws. I can't tell you how many times we've lost screws because we didn't put them back in the hole where they need to go. So checking with my meter, I go on these bus bars right here. You can see it's live, right? It's live. So here we go. We're gonna turn them all off, except for the fire bell. That one has a lock on it, so we're just gonna leave it. And then we're gonna cut the main breaker, just like that. And then I wanna check that it's dead, turn it back on, check that my meter works. There we go, it's on. Off again, check it the last time. We're safe. That's how you do a live dead live test to make sure that this entire thing is off. All right, so as you can see, these are the wires right here. This is a newer house, like I was saying. These wires go right inside to the garage, into that junction box. So Let's take a minute. Let me show you how to get the wiring in if you have an older panel that looks something like this, so that you can get a flexible conduit from the bottom of the panel down into where you need to go to mount an EV charger receptacle or an actual EV charger in your garage. This is from a previous video that we had, so take a look really quick. What we need to do is we need to figure out where we're gonna go into this panel. So I'm gonna actually, this one's already kind of knocked out. We're gonna utilize this one right here, this knockout. If you look here, this center knockout that's already kind of knocked out, that's a 1/2 inch. For the EV charger, I need a 3/4. So I need to get this knockout out as well. So what you do with this is you just work this thing, get these pieces out, and then we have to get this one out right here as well. So I just take a flathead screwdriver and just beat it. Beat it in a little bit like that. And there's no special magic to it. You just got to get this piece out. And then once you can get something on there to grab it, it should just come right out. So again, the most important thing here is to make sure that the panel is off. Do not mess around with this live. And that's why I always say use a licensed electrician. This is not really a task that you should try and take on yourself. I need to find exactly where this hole is so that we can go down and straight out. So to do that, I need to find a reference point that's the same on this side as it is on the inside of the garage. So I usually use the corner of the stucco or of the siding. So I'm gonna take my tape measure and put the end dead center of that hole right there. You see that? So we're going right there, and I'm gonna hold this with my finger, and then I'm gonna come out, and there's the edge of my stucco right there. So I'm looking at 41.5 inches. 41.5 inches to this edge right here. Now we can take that and go on the inside. I have this plane right here. So then I take my tape measure right here and I line it up 41.5 inches. And that's gonna put me right there. The other thing that I always like to do is if there's a box, if there's something here in this area that I can open up, I wanna open it up. Now I can get my phone in there, or I can even get my camera scope and I can send it in there just to make sure that I'm not gonna hit anything when I drill through here. So if you don't have something that you can open up and look in, just make sure that when you drill it with your hole saw, that you go really careful and you don't shove the hole saw all the way in the wall there. You just wanna go a little bit in so that it just breaks through the drywall, and then you can get your finger in there and make sure you didn't hit anything. So here, I've already checked it and we're fine. So this right here is called an LB. So we're gonna use an LB to come out, and I'm gonna have it go sideways this way. And then we're gonna go out the side here and up into the bottom of our EV charger receptacle box. It's gonna be FMC, or flexible metallic conduit, going up into the panel. What I wanna do is I need to make sure that whatever hole saw I use is big enough. I don't want this thing sticking off the wall like this, I want it in. The right size hole saw to do that is 1 3/8. So we have measured over, we know where we're going here, so now I'm gonna drill my hole. And like I was saying, you wanna go nice and easy. We don't wanna accidentally hit something behind the drywall here. So we're just gonna go nice and easy. As soon as it punctures through, I pull it out, pop that hole in, put my finger in here, and we're good to go. Now this fits perfectly into that hole where the LB can sit flush right on the drywall. So that's exactly what we want. We're still gonna do a little silicone around this just to make sure that no bugs or critters can get in or out of the walls. But yeah, we're good. All right, so the next part is I need to get my flexible conduit from inside the garage up into the panel. So I like to just use a little piece of solid wire. You can also use a fish tape. So what I do, because we lined up our hole nice and center, we used the center of the hole here with the edge of the stucco. I should be able to go pretty straight down and find that wire on the other side. So what I do is I put a little bit of a loop on the end in case I need to hook it. If it's back in the wall, I can grab this with another piece of wire. So fishing this down is easiest if you have 2 people. So Paul's on the inside over there and he's gonna hook it and pull it out. So it's coming down, Paul. So as you can see, we were able to get the wire right through the wall here. So now what we're gonna do is we're gonna take our flex And we want to figure out what that measurement is from the bottom of the panel to this hole and go just a little bit longer. So I know that it's just about this long right here. So with the flexible conduit, you just take it and break it open, pull it, use some tin snips, and just snip it. So you're just using that edge right there. I like to clean up these edges right here so that it's nice and good. And then we're gonna take what we call a Jake or a flex connector. So what we wanna do is we wanna take the flex connector and just screw it in here. Wanna get it all the way into the flex, all the way where it needs to be, seated all the way down, just like that, okay? Take the lock ring off. So we wanna take this flex and we wanna slide it up over this wire right here. Now, when you're doing this, you wanna have somebody on the other side holding the wire so that we can slide this up and get that connector up into that hole that we knocked out in the bottom of the panel. So you'll see we're using the wire as a guide and we're gonna shove it up. Go ahead. There it is. All right, you see it pop up in there? Hold it tight over there. So as I said, this is best with 2 people. Once that comes up and in, you can just get your lock ring and very carefully just get it on there until it's nice and tight, and then we just beat it even tighter. And there it is, it's locked in. Now that everything's off in the panel, this is the only section right here that is still live. So you can see here, they have it nice and covered. Let's put this back on. After you've done all your live dead live testing and everything is off, you wanna do lockout tagout. So we wanna make sure that we're safe and that nobody comes walking by and turns the power back on, right? You can either use one of these breaker locks right here that goes over the breaker itself, or in this case, we're just gonna close the cover, put the lock on here, and you're good to go. And then whoever's working on it needs to hold on to the key. Here at this house, what we are going to do, now you have a couple different options. So we have the weather resistant receptacle right here, industrial rated lighter electric. You can, if you have a junction box in the wall, you can install this in there. And then you can put a cover plate right over it just like that. If you order the one from Lighter, it comes with everything that you need, so you're good to go with them. I don't really like this setup. You can do it this way, but I prefer to use this big box. And I will tell you why. Right here on the side is a lock. So if this is going outdoors, you can lock this in place so that nobody can pull this out and steal your charger if you have the plug-in charger. The second thing is, inside a garage like this, look at all these toys. We got skateboards, we got boogie boards, we got guitars, baseball stuff. We got strollers for babies in here. They have kids at this house, Paul. Look how big these openings are, dude.
Yeah.
Any kid playing in a garage could potentially stick something in there, right? Now, if they only do one side and they're not grounded, they're not gonna get lit up. But if they're in a garage barefoot and they shove something into this, there's a good chance that they're gonna get shocked. You know what I mean? On top of that, we don't just have 120 here, we have 240 right here. So any garages that I put these in, I always like to have a cover, just like that has a lock on the side of the cover, so that kids, once you plug your car charger in, kids can't get their hands in there. You know, we're talking toddlers. Hopefully your 15-year-old is not gonna come out here and shove something in there. But I want it to be as safe as possible for whoever lives here. Yeah. And if the homeowner that's living here doesn't have any kids, they might sell their house someday. So here we already have the junction box. So what we're gonna do is we're gonna utilize these 4 screws, and we're gonna go right through the back, and we're gonna tap these out in the same pattern as that, and then utilize that same box. And we're gonna drill 1 hole in the center and put a plastic bushing in the center and let the wires come right through. Just like that. Put the screws back in here so we don't lose them. That grounding lug right back there, Paul, that's the biggest issue in all of the other boxes that we use. There's not enough space. So we actually, remember, we have to remove that lug out of there so that when we shove the receptacle back in, it doesn't clamp down and ground out and trip. Yeah. I've seen it happen where you Try and train the wires as best you can, but then unfortunately that ground lug right there is sticking out too far and it pinches the wires. So that's another reason why I love how deep this thing is, dude. I want to take this off right here. All right, so as you can see, we have wires already in there, ready to go. These are Romex, so again, these are rated for 55 amps only. You cannot use these for a 60 amp charger, but you can use them for a NEMA 1450 outlet like we're doing here. We're gonna use this as our template. I wanna get this thing mounted. Make sure that it's high enough up with the screw pattern so that the bottom of the box is covered. Get it lined up just like that. Make sure we stay square. Just gonna mark them. Make sure you're nice and straight and up and down so that these line up. All right, now we have our pattern. We need to tap it out all the way. There you go. We're gonna drill our hole right in the center. We've got space everywhere, so great. Snap it in, so just like that. There we go. Get it up. They didn't ground the box, Paul. Yeah, if you see right here, this ground wire is supposed to be landed or tailed off from that screw right back there, that screw hole. So this is a ground tail. We're gonna utilize this and then some extra number 10 gauge wire. We can't hide the splicing behind in this box. We need it to be done in the big box. So now the box is grounded. We're gonna pull this forward. Get all these wires in here. Just like that. Look at that. Ain't going nowhere. We'll pop the plastic bushing in there so the wires are protected. It's nice and level, lines up with the seam here. Let's splice these, Paul, and then land our ground up in there. And then this one is already grounded right there. So yeah. Do that and then we can land the rest of the wires. All right, here we go. So we want to cut these grounds a little shorter, just like that. Make sure we have enough. I'm gonna use a red wire nut, what's rated for 2 number 10s and a number 12. Really want a good connection with these. There it is. Now this is where a lot of receptacles fail. When we go to install the wires into the terminations here, these screws in a lot of the outlets just strip out. They're cheap, they're not good. This one is amazing. These guys took so much time in the engineering to make sure that all of these components are high quality. So what I like to do here is check the orientation of the outlet. When you buy the plug for the EV charger, the ground is gonna be up. So make sure you go this direction. So what we have here is our black, our red, and our white. It says it right on there, white, and then X and Y. So you could do these two, it really doesn't matter. You can go black or red on either side. This is the one that matters, the one that says white. So what I do is I'll look at it and I'll fold these wires in so I know that it's gonna be about that far back. So I'll try and see if I can't get the bend on here to where it fits perfect, right? So this is bottom. It's about that far back. You can even measure it if you want. So I'm looking at to center, it's about 1 1/8 inches, right around 1 inch, 1 1/8 inches. So I'm gonna be, when that thing is set, so I'm too far back right now. So it's actually gonna be a little bit more forward, but I like to get it set where there's a little bit of play either direction, right? And then going up, I know that this thing's gonna sit right here. That termination is right here lined up with this termination right here. So to put this in place, I can measure down. So it's about 2 inches to right here where the screw holes are. So I want to be about 2 inches up right there. So I need to just hack a tiny little piece off of that. Just like that. So that's literally right where it's gonna sit. So that's how you want to set up the wire. So when you go to put it in, it fits perfect. You know what I mean? Okay, and then we'll go, just because I like black on the left, we'll go black on the left here. Now this one's gonna be up a little higher than the other one, right? Same depth out and in, but it's gonna be up a little higher. So I wanna go like this, and then the red is gonna be like this, right here. So we're looking at something like that, okay? So if you set yourself up in the beginning the correct way, then you're setting yourself up for success, right? To where this thing is gonna go in, no problem, nice and easy, good to go. Very carefully, without scoring the copper, I'm gonna twist this around like that, okay? Pop it off. And we'll do the neutral. Like that. Don't score it, you wanna rip it. There we go. Pull it off. I wanna take this cover off. It makes it a lot easier to work with. If you get the screwdriver up in here like this, and you pry it, you can pop the cover off on both sides. And then on this one, I'm actually gonna have to take this out of the cover. So I'm just gonna use this to get them snug, and then we'll actually use the torque wrench to tighten them down to this torque spec. Paul, can you check in the manual real quick what the torque spec is on these? All right, so you wanna make sure the conductor's all the way in there. You don't wanna go too tight with this. Just about that, that's it. Enough to hold it. Hold it in because it wants to come out. Just like that. Again, not too tight. You do not want it to be too tight. There it is. All right, so 75 inch-pounds right there. Our torque wrench, let me see it. Our torque wrench is in foot-pounds. So to find inch-pounds, you divide by 12. So 75 divided by 12 is what, Paul?
6 1/4.
6 1/4. All right, now I need your help on this, Paul. I'm gonna hold the outlet and you're gonna torque it until we hear a click on the torque wrench. There it is. There it is. There it is. Check the next one. No, check the ground. And they're good on the ground. Look at that. Very good. Tuck this in, bend those wires where we want them. 1 and 2. And then this goes right in that little slot. 1. There it is. Very clean. So like I said, industrial rated, and this box has plenty of space on it and a lock on the side. That's what you want to look for. All right, let's go do the panel side, Paul. All right, so I got to call a couple customers and pull a permit real quick. Get this wired up and then we'll show how everything's wired up, all right? Okay. You good?
Yep.
All right, thanks. All right, so you got it all wired up, Paul?
Yeah.
All right, so we came from down here and the wires go up and through over here. So the difference here from a normal breaker to a GFCI is that this provides ground fault protection in the event that water or anything gets into the garage. So what we see here is the hot, and the neutral in the middle. So the neutral coming from the outlet itself plugs in on here, and then there's a white wire, if you see it right there, this coil wire, that actually comes off the breaker and lands on the neutral bus right there. All right, so make sure we have our safety glasses on, and what you wanna do here is never stand right in front of the panel just in case something were to go wrong. So you wanna stay off to the side like this, turn the main on first. That's good to go. We're gonna check voltage going up the bus bars. So again, we're gonna check here and here. We got voltage, you see that? 240. And then you wanna turn all the branch circuit breakers on. So get these all turned on. Turn that one on, there we go. Good to go. Good, and then I like to test the GFCI breaker first, that the GFCI is actually working. Trips in the center, turn it off, go back on, good to go. And then what we wanna do is we wanna do a voltage check, make sure that the breaker is not bad out of the box. There we go, 241, good to go, to neutral, 120. Here we go, 120, good to go. Let's go ahead and get this closed up, Paul, and then let's go do a voltage check on the other side.
Okay.
So once everything's powered on, we're just gonna do another voltage check right here. So there are 2 hots, 240, good to go, to neutral, 120, good to go, 120, 122, good to go. And then we're gonna go from hot to ground, 121, and then to the other side, 121. Very good. I love it. Well, that's it for today, guys. Thanks so much for watching. Special shout out to Lighter Electric. Awesome product, industrial rated, NEMA 1450 outlet, rated for EV charging and any other high draw loads. If you want to pick one of these up, I put the link down in the description. And as always, thank you so much for watching. Appreciate you. Take care.